Hello, this is Professor Kuehn. We've been talking about Copernicus's 1543 book on the revolutions of the heavenly spheres. We're studying his book 1. We've gotten up to about chapter 4 of book 1, and this is contained in chapter 11 in A Student's Guide to the Great Physics Texts, volume 1. In my last lecture, I focused at the end of the lecture on how Copernicus was simply trying to reorganize the celestial spheres that are carrying the planets. What he was doing is he was focusing on the fact that one still needs to refer to celestial spheres in order to account for the motion of these planets. And moreover, that these spheres ideally should be moving at a constant rotation rate. That is, they shouldn't be speeding up or slowing down. But the question then arises, why is it that it seems like certain celestial bodies, like the sun, for example, appear to move faster and slower at different times of the year? For example, as the sun is progressing through the zodiac, sometimes it appears to be moving faster through the zodiac, other times it appears to move slower through the zodiac. We talked about how the ancients referred the celestial spheres to a center other than the center of the earth. So they believed that the spheres on which the planets and the sun were riding were not exactly centered on the earth. This could explain why the sun appears to move faster during some times of the year and slower during others. So when the sun is closer, it appears to be moving faster. When it's farther, it appears to be moving slower. And this can be the case even though the sphere on which the sun is riding is rotating at a constant rotation rate. This problem is even more pronounced when we talk about the motion of the planets. So before I leave chapter 11, I want to say a couple of things on the motion of the planets. If we put the Earth, again, according to the Ptolemaic model, if we have the Earth at the center of this celestial sphere, let me draw the sphere of stars way out here. Not a very good sphere, but there you have it. This is the sphere of stars. And let's suppose that we imagine the sun is riding on a sphere that is going around the Earth also. Remember that they believe it's riding on a sphere, but it's not exactly centered on the Earth. And then let's talk about the motion of Venus. So Venus appears to be going around the Earth as well. So let me make a couple of notes here. So Venus, like the sun, appears to progress through the zodiac. Over the course of about 365.25 days. So if you were to look up toward the sun, you would always see Venus in the same vicinity of the sky as the sun. So I might draw a dot right here representing if you were standing on the Earth, so I'm going to draw you standing right here, looking up. If you look up at the sun, Venus will always be right near the sun compared to the background stars. So if we were to imagine breaking these background of stars again into 12 regions, the regions of the zodiac, over the course of the year, the sun would be progressing through the signs of the zodiac, and Venus too would be progressing through the signs of the zodiac. Okay, so that's one point to keep in mind. The second point to keep in mind is that, I'll say, but Venus also sometimes advances more quickly than the sun. More quickly than the sun. In other words, it passes the sun. And other times, it falls behind the sun. Okay? So this is something that if you've studied stellarium a little bit or gone outside and looked at Venus, you'll notice, for example, right now it is about October 25th in 2020, if I go out in the morning at about 6 in the morning and I look to the east, the sun will not yet have risen in the east, and yet Venus will be up in the sky already. So it rises and then the sun rises, and then a little bit later Venus sets and then the sun sets. But over the course of the next several months, we're going to notice that it's going to be approaching the sun. In other words, after a few months, the sun is going to rise first, and then Venus will rise second. So I won't be able to see Venus in the sky in the morning because the sun will already be up. But then in the evening, after the sun sets, Venus will still be up in the sky, and Venus will set behind the sun. It will be the evening star is what it's called. In any case, sometimes Venus is moving in front of the sun, sometimes behind the sun, but it's always near the sun in the sky. So Venus always stays nearby the sun in the sky. So how, this isn't something Copernicus just noticed himself. This is something people had known about for centuries. So how did the Ptolemaic model account for this? Well, in addition to Venus riding on a sphere going around the Earth, there was also another sphere which was called an epicycle. So the center of this epicycle was in a sense locked to the sun. So as the sun goes around through the zodiac, the center of this epicycle also goes around the zodiac. But now, in addition to rotating around like that, this sphere is rotating. So sometimes Venus will be over here. So Venus is actually riding on this epicycle, and sometimes Venus will be over here. So from the perspective of someone standing on the Earth, when you look up, sometimes Venus will appear to this side of the sun, and sometimes Venus will appear to this side of the sun, but it will always remain kind of in the vicinity of the sun. Okay? And this, by the way, is also true of of Mercury. Mercury always stays in the same vicinity of the sky as the sun. So Mercury and Venus exhibit the same kind of behavior. Now, it's also true, so maybe I'll just note that. This is also true of Mercury. Okay? And it's also true of Mars, Jupiter, and Saturn, but with these three, with one notable exception, or maybe I'll say one pronounced difference. And that is, while they're sometimes progressing ahead of the sun, sometimes falling behind the sun, the center of their epicycle is not locked to the sun. In other words, for Mars and Jupiter and Saturn, they can be in a completely different part of the sky as the sun. So if I were to label these points 1, 2, and 3, they would sometimes progress more quickly than the sun, sometimes more slowly than the sun, but points 1 and 3 are different for Mars, Jupiter, and Saturn. We'll come back to this again later. Okay, but the point that Copernicus is really making at the end of this chapter 11 is one can use these constantly rotating spheres to account for the motion of the sun and the planets. But again, what Copernicus is going to do is he is going to argue that the ordering of the spheres is not as elegant in the Ptolemaic system as the one that he is going to come up with. So if we look at the very bottom of the paragraph on page 140, he's talking about these motions of the sun and the planets. He says, "For this reason, I think it necessary above all that we should note carefully what the relation of the earth to the heavens is, so as not, when we wish to scrutinize the highest things, to be ignorant of those which are nearest to us, and so as not, by the same error, to attribute to the celestial bodies what belongs to the earth." So what he's hinting at here, remember this is the very beginning of his book, he's hinting at here that we don't want to suggest that the planets and the sun are exhibiting all these complicated motions, when some of that could be attributed to the actual motion of the earth itself.